All right, so in the last video we talked about conditional statements or if-then statements. So now we're going to talk just a little bit about writing the converse of those statements. So the converse you can think of as if the conditional statement is P implies Q, so our conditional statement is P implies Q. Well, the converse would then be Q implies P. So in other words, we just take our statements, our hypothesis and our conclusion, and we flip them around and we just give that statement. So in our last example, we had, let's look at the top one. If you live in Nashville, then you live in Tennessee. So we're going to flip that around and say, if you live in Tennessee, then you live in Nashville. So this is the converse of our previous statement. So our previous statement was if you live in Nashville, then you live in Tennessee. The converse is we switch the hypothesis and the conclusion, and we make the conclusion the new hypothesis. So this says, if you live in Tennessee, then you live in Nashville. And this brings up a really interesting conversation about whether the converse is always true. In this case, the converse is not true because you could live in Tennessee and not live in Nashville. So this one is false. There are going to be some converse statements that we find that are true. And so we will talk about those. So let's take a look at a few more. So one of the other ones we looked at was if a quadrilateral is a square, then it has 4 right angles. So if a shape has 4 right angles, then it is a square. Now, the question is that true? Is it true that if a shape has 4 right angles, it's a square? Well, no, because you could have a rectangle, so that one's false as well. Let's look at one more. So, let's look at the bottom one. If a number is prime, then it only has 2 factors, 1 and itself. So again, we're going to take these and we're going to switch them. So we're going to take our hypothesis and it becomes our conclusion, and our conclusion becomes our hypothesis. So our new hypothesis is if a number has only 2 factors, 1 and itself, then it is prime. Interesting. Now, is this one true? You might think about it. But yeah, I mean, that's the definition of a prime number, is that any number that has only 2 factors, 1 in itself, is a prime number. So this one happens to be true. So this conditional is biconditional, is sometimes what it's called. But basically what it means is that if we write the converse, remember these are all converse statements. If we write the converse of this conditional statement, then it happens to be true. So again, for the converse, normally we have our hypothesis and a conclusion. And when we write the converse of a statement, we swap places with that, and this now becomes our new hypothesis, and our hypothesis becomes our conclusion.